from the homework that I gave you. These are the questions, and let's do some simple correction. So from the homework, we shall do one or two numbers. And somebody said the number for benzoic acid, it is the one which was a bit hard. So we shall do this, and then benzoic acid, and probably, anyway, we shall see. Now, the first one wants us to calculate the degree of ionization, okay, of a 0.1 molar solution of ethanoic acid. And we have Ka, okay, and our Ka, it is 1.8 times 10 power 3, negative 3 mole squared per decimeter. I think it is per decimeter 6. Is it 6? No, it is moles per decimeter cubed, I think. Anyway, I showed you how to do. It's not mole squared. And we have our concentration C, which is 0.1 molar. And the question wants the degree of ionization. Now remember, we derived the formula and we came up to the final formula, which we can use to calculate the degree of ionization as the root or the square root of Ka divided by C for a monobasic acid. And we can see that ethanoic acid, it's a monobasic acid. It is just COOH. So we shall just substitute in this and we get our degree of ionization. So it shall be 1.8 times 10 power negative 3 divided by 0.1 molar. So if you don't still remember this formula, you can still derive. It is okay. You can still derive. You start from the acid, you dissociate it or you ionize it, and then you produce your base, so your ethanol with ions and the hydrogen ions. Then you know at t equals 0, or at the start, you have 0.1 molar solution, but at equilibrium, so that you have 0 of this and 0 of that. Then at equilibrium, if you form X of ethanol weight and X of hydrogen ions, and from mole ratio which is 1:1, then we shall be able to see that X of ethanol weight ions would have dissociated. So therefore, what remains at equilibrium is simply 0.1 minus X. Actually, the question wants the degree. So this one is going to be alpha C, okay? And even this one is alpha C, okay? And so it will be 0.1 minus alpha C. And so when you substitute, you come up with this. And you substitute your values, you get your final answer. I hope that one was as easy as nothing. Now for number 2, you're given the degree of dissociation, alpha. And in this case, it is 0.2% ionized, okay, at 25 degrees Celsius at room temperature. A moment. So we have our alpha as 0.2%. In other words, our benzene is 0.2% ionized, our benzoic acid. And we want the Ka, the acid dissociation constant, we have the C. Okay? We have the C as 0.1. So from this data, can't we determine our dissociation constant? And since our benzoic acid is monobasic, this is benzoic acid, sorry for that. This is benzoic acid, benzene, and a COOH. Okay? So it is monobasic.
Mister,
Yes.
share the screen.
Oh, I'm not sharing the screen. We can see that benzoic acid is a monobasic acid. And so our alpha, it also conforms to our general formula, which is Ka divided by C. Now, if alpha, or if the degree of ionization is given in percentage, it means it was got by multiplying the degree here by 100. Okay? So if you want the alpha, it will just be 0.2 divided by 100, which is 0.000, no, 2 zeros, not 3 zeros. So this is our alpha that we shall use. So if we substitute, it will be 0.002 should be equal to the square root of Ka divided by C, which is 0.1. If we square here, okay, and then we multiply. So it will be 0.1 times 0.002. It should give us our Ka. So the answer that you shall get here is going to be your Ka. What's the answer?
0.0002.
It is 0. Even when this is
Zero
squared?
zero.
No. Oh, sorry, I forgot to put it. The 0.002 is squared. It is squared. It is 0.
0.000004.
00. How many zeros? Are they 3?
Mirundo mukabwa.
Oh, they are 6 zeros. So this is 1, 2, 3, 4, 5, 6, 4. So in other words, it is 4.0 times 10 power negative 1, 2, 3, 4, 5, 6, 7. So I hope it is correct. I hope this is okay. It is, eh? Yes. Then units, it will be moles squared. Is it moles squared? No, it is moles per decimeter cubed. Per decimeter cubed. So it is as simple. Now let's do for one base. Maybe let's do for trimethyl, for methylamine. So here, it's okay. Here we are finding, we are doing this number. Okay, we are doing the number and we wrote the equation. Then we wrote the concept, the Kb, the expression for Kb, and then from the expression we are calculating the concentration of OH ions. And so from this expression we can get the concentration of OH ions. And then the assumptions made: one, it is at equilibrium, the concentration of CH3, NH3 plus is equal to the concentration of OH. This is the assumption that we've been making. And so from this assumption, you can see that's how we've gotten this. Okay? And then from this, we got the concentration of OH. So basically, that's how this question was simple. That's how this question was interesting.